Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 10, and this problem asks us, would 16, 20, or 22 annulene be aromatic if each ring is planar? So to determine if something is aromatic, it needs to follow what we call Huckel's rule. So what does Huckel's rule says? It says that in order for a molecule to be aromatic, it must have 4n plus 2 pi electrons. So what does that mean? It must have 4n plus 2 double bonds or alkene double bonds. So now let's look at benzene. Benzene we know is an aromatic ring. So if we use an n here, it's important to know n can be any whole positive integer. So it can be 0, 1, 2, 3, dot, 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 whatever it is. So if n is 0, then the possibility can be 2 pi bonds. If n is 1, we can have 6. If n is 2, we can have 10, and so on and so forth. If n is 3, we can have 14, and so on and so forth. So what we know is that in our benzene ring, we have 1, 2, 3 double bonds, and remember each double bond is composed of 2 electrons. So in essence, we have 2, 4, 6 pi electrons. So yes, benzene is aromatic because it follows Huckel's rule of 4n plus 2 pi electrons. Well, what about these molecules here? So what about 16 alanine? So let's determine that. So how do I get 16 pi electrons? Well, this actually follows the 4n rule. So n, in this case, is equal to 4. So 4 times 4 gives us that 16. So this is actually what we call an anti-aromatic compound. Why? Because an anti-aromatic compound follows the 4n rules for the number of pi electrons, while aromatic compounds follow the 4n plus 2 rules of pi electrons. So 16 pi electron annulene is anti-aromatic. What about 20? So how do we get 20? Well, if we do 4 times n, if we sub n for 5, 4 times 5, that gives us 20. So this molecule is also anti-aromatic. Well, now what about 22? Well, if I do that same thing, 4 times 5, but now I do it plus 2, so following Huckel's rule, I follow the formula here, will n equals to 5. I get 20 plus 2 equals 22. So this molecule, a 22 pi electron version of this molecule, yes, this one is aromatic, while the 16 and 20 are anti-aromatic because they follow the 4n rule. But this 22 pi electron follows the 4n plus 2 rule, which is for aromaticity.